Bueno, pues muchísimas gracias a todos. De verdad es un gusto verlos aquí. Y pues bueno, estamos terminando nuestro ciclo de paneles de interés sectorial y vamos a empezar con la primera presentación global. Y pues bueno, yo tengo el gusto y el súper placer de presentarles a Roosevelt Mosley. Roosevelt tiene 29 años de experiencia en el gremio actuarial y actualmente es consultor para Pinnacle Actuarial Resources. Estudió un BS en Actuarial Sciences de la Universidad de Michigan y tiene la certificación de Fellow en la Casualty Actuarial Society. Es miembro de la American Academy of Actuaries y está certificado como especialista en análisis predictivo. Sus áreas de interés y de desarrollo son analytics de redes sociales, inteligencia de negocio, impacto de propuestas regulatorias, analytics de siniestros, entre otros, por lo que van a poder consultar gran diversidad de papers e investigaciones que él ha hecho a lo largo de su vida laboral. Resalta el título de uno de ellos, que es Actuarios en la era de la tecnología y los impactos del COVID en la industria automotriz, lo que significa para el futuro. A la par de todos los logros técnicos que Roosevelt ha realizado, ha sido seleccionado como el presidente de la CAS, posición que ocupa actualmente y por lo cual nos sentimos muy honrados y orgullosos de contar con su presencia. Bienvenido, Roosevelt.
Thank you, and thank you, Mabel. I don't understand everything she said, so hopefully it was good. It is my great pleasure to be here with you. So thank you very much for the invitation, and thank you for tolerating the fact that my Spanish is terrible, and so to tolerate the fact that I could do this in English. I was happy when they asked me to do this. I've had the opportunity to talk to a number of different people about actuarial models, and I've had a chance to do it in a number of different places around the world. And it's always interesting to me to see how the use of models in actuarial science and actuarial work has progressed, has moved forward. And I'm happy to have that conversation here today to talk about how actuarial models are being used and then ultimately how they will be used in the future. There are a couple of things I want to mention before I actually get into it. First, my background, as I think you heard in the introduction, my background is mostly in general insurance or property and casualty insurance. However, the concepts as we talk about big data and models especially translate across all different lines of insurance. And so hopefully you will be able to take at least the concepts that we're talking about and translate them to work that you do if it is not in the general insurance space. Secondly, and I heard I've been using Google Translate this morning, and so I heard earlier there was some discussion about data and machine learning and big data, and a lot of times those discussions are used in the context of things like predictive models or predictive analytics, but hopefully, as we go through this, you will also understand that the concepts that we're talking about can apply across lots of different types of models. If you think about catastrophe models, which I know is the subject of the next session, a lot of different types of models can apply these kinds of techniques. And so again, don't just think about the predictive models, although a number of the examples I give will be in that context. Think about it from a much broader perspective. The last thing, I'm happy to obviously bring you greetings as well from the Casualty Actuarial Society. I have the honor of now serving as president of the Casualty Actuarial Society through next November. And the Casualty Actuarial Society is focused, well, the only actuarial association in the world that is focused solely on general insurance. And so, again, it's great to be here with you today. So I wanted to take a quick moment to provide some definitions of exactly what I'm talking about. But just like good actuaries, as we talk about the future of something, where we start is to actually go back and look at past and look at history. And so I want to do that because really to understand the future of actuarial models, I think it's helpful to understand where we are, where we have been and where we are today. So let me first start by kind of looking at this idea of at least what I consider to be a model life cycle. And again, you can apply this to any type of model. And I'll actually use as an example, I was going to use a different example, but as I was sitting here using Google Translate today, it really got me thinking about the idea of a model life cycle, and it helps to also provide some insight as to where the future of actuarial models will go. So if you think about what had to happen before the Google Translate app ended up on my phone and I was able to use it this morning, at some point, someone at Google decided that, hey, it would be cool to have a translation app. And so what did they have to do? To build this app, they had to get a lot of information. They had to get a lot of data on translations. And so I don't know exactly where they went and got the data from, but they probably got a lot of information on how to translate conversations, to translate things from Spanish into English, and then built some algorithms to help them do that better in a more efficient manner. And ultimately, they got to a point where they decided, hey, this is ready to go. Well, I can tell you from this morning that I'm pretty sure they did not get a lot of data from actuarial seminars to help define how to translate from Spanish to English, because while I was able to follow a lot of the concepts, there were a lot of things in there that I was pretty sure people weren't talking about, like YouTube and hobbits. So in other words, at some point, the model had to be put out into the world for a real application. And then that application over time gets better and better as more and more data, as more and more information feeds it. So what am I saying? Well, if you think about the idea of an actuarial model or the model life cycle, effectively, it kind of starts and ends with a business question. It's an application. There's a particular thing that you're trying to get to. And then there are the really kind of three big areas, and they sort of work around that circle here. The three big areas are data, development, and deployment. So you've got to have data, you've got to have information to help you answer the question, and then you've got to use that information to actually help develop the answer. That's sort of the modeling phase that we'll talk about. And then you've got to do something with the results. You've got to actually use the results in some way. That's the deployment. And what happens is it ends up becoming a continuous cycle, because as you deploy it, much like Google deployed the Google Translate app, as you deploy it, you realize that when the model is put into situations that it may not necessarily have faced before, it may not necessarily operate the way you think it should. Now, the cost of Google Translate being wrong this morning was fairly low. There's not really much that's going to be harmful because Google Translate missed some concepts. In the work that we do as actuaries, sometimes the cost of missing or cost of being wrong can be high. And so part of the challenge then is, how do we continually innovate? How do we continually improve upon what we do in actuarial models in order to help us do what we do better? So I'm going to come back to that life cycle idea and talk about that a little more, but that's the context I want to put this discussion in. So as I mentioned, there are three elements. The first is data. And so again, if you want to understand sort of how old historically we looked at data and how it's moving, you could understand the idea of data as maybe drinking from a water hose. And again, me growing up, that was actually kind of fun. We would drink from the water hose when we were outside playing and we would get tired. But if you think about the way that data is coming at us now, it's more like that. It's coming at us like water out of a hydrant. And in this picture was from a few years ago, but it's probably coming at us a lot faster. And so when we think about the future of actuarial models, one of the things that we're going to have to think about is how do we handle data that's coming at us that fast, and how do we actually do something with it that's going to be useful and helpful to our customers. Okay, so let me take a step back and sort of define this idea of big data. It's a word that gets used often, and I want to really quickly just highlight at least what I mean when I use it. And sometimes you'll see this isn't, I didn't make this up. This has actually been used in a lot of places. You'll see 3, sometimes 4 V's. The first is volume, a lot of data, and we're dealing with more and more information today. The second is velocity. How fast is it coming at you? And that's the second sort of characterization of a lot of the data that we have. And the third is variety. It comes at you in a lot of different ways. We're not just dealing with data in a database anymore. We're getting textual information. We're getting visual information. We are getting audio information, recorded transcripts like Google Translate. And so there is data, there's information coming at us from a lot of different ways, from a lot of different places, and coming in a lot of different ways. And so the fourth one is, you may hear it sometimes, it's called veracity or accuracy. For me, at least, that doesn't really help define big data. Any data that we use, we want it to be accurate. But sometimes if you hear the fourth V, that's typically the fourth V that you'll hear. But again, where we've been and where we're going, all of this isn't slowing down. If anything, it's continuing to get faster. It's continuing to change more and more. So the question is then, how do we deal with it? The second piece of it is as we said, the analytics. And again, the concept of analytics or model development really is pretty universal. And it's the idea of taking a system, taking something that we're analyzing, be it insurance prices, be it claims, be it marketing. It's taking that and trying to break it down into a combination of its parts so that we can understand from a technical perspective what the data is telling us. We can apply our actuarial skill set so that we can take it and put some logic around what the data is telling us, so that ultimately we get to a point where it is useful for the future. It's predictive. And I'm going to come back to that, because if we don't get to the point where it's actually useful for the people that use actuarial services, either our ultimate customers, the companies that we work for, then it doesn't matter how complex or how great the model is. If I can't use it, then ultimately I think we've probably failed somewhere. So keep all of that in mind as we go through this. So let me come back to this idea of data, and I will. You could add much more to this slide, but I really use this as just representative. Historically, if we think back, well, to when I started my career, which was 30 years ago, a lot of this data either didn't exist or just wasn't there. But we had a lot of data that we used from inside companies that the companies would collect on their customers to help us determine whatever that outcome we were trying to get at. If we were trying to set prices, we would look at historical data to help understand what those prices were. Well, over time, because of the increase in technology, because of the increase in information, the data that we've been able to get internally has grown by leaps and bounds. There's much more data today that a company is capturing internally and can access and do things with than they could historically. A lot of that has been enabled by technology. A lot of that is just companies getting better and better about what they do. But then the other transformation that began to really explode is companies, even companies outside of the insurance and the actuarial space, realizing that they had a lot of data that could potentially be important for insurance companies. And so if you look at a lot of the different types of sources, there were sources that again, we weren't even thinking of 30 years ago, but now that become either pretty commonplace or you begin to understand pretty easily. Everybody's carrying a mobile computer in their pocket right now. Some of you are even on them right now. But when you're carrying those mobile computers around, guess what they're doing? They're generating data. They're generating information. And that data, that information, whether you believe it or not, is being used by somebody for something, whatever that something is. And even in insurance companies are starting to access that kind of data. The vehicles that we drive, they're getting smarter, they're being built with more technology, and guess what they're doing? They're generating a lot of data, a lot of information that is now beginning to be accessed and used. More and more cases, even the homes that we live in, all the homes have Wi-Fi, and as a result of the Wi-Fi in the home, I can now connect my refrigerator, my TVs, my whatever thing that I'm using, all of that can now connect into the home. And so while I'm here in Mexico City, I can actually tell a lot about what's going on at my home in Dallas simply by pulling up my phone because of all the things that are connected to it. And so now all of that information is now becoming available to insurance companies. And so if you think about the sources of that data, the sources of that information, and how much data that's generating, how much information that's generating. If you ever seen data that comes out of a vehicle telematics system, you can literally be collecting data at the sub-second more frequently than a second, telling you what's happening with that vehicle at the time. And so you begin to see how fast that data is coming. There's also external influences that are impacting us. So again, the next session we'll talk about natural catastrophes, but that's influencing the data that we get and how things are changing. Weather patterns, wearables, the Internet of Things, all of the things that are happening around us, it's feeding into this idea that data is flowing and is coming at us much faster than it ever has in the past. A couple I'll just look at a little more closely. This idea of telematics or usage-based insurance. This really has the potential, at least it hasn't yet in most jurisdictions that I've seen, but it has the potential to really transform how we price automobile insurance. So there are a number of different ways to approach it, but either through your mobile phone and an app or through something that's plugged into the vehicle, the insurance companies are able to monitor very detailed, specific data on how that car is being driven, and then able to use that information to determine how to price that vehicle appropriately based on how it's being used and how it's being driven. So again, many of the applications of this haven't gotten to the point that they could get to. So if you think about knowing how that vehicle is being used at every second, and now being able to make real-time determinations, use that real-time information to truly understand the risk, it could really get to a pretty impressive place. It hasn't yet, but that's the kind of information, again, that's out there and being used. I talked about connected homes earlier. This is just it's just a small list of things that are available, but there are things that can be plugged into the home all over the place, again, to help determine how that home is being used, the potential for risks at that home. Is there potential for water to damage the home? Is there potential for electricity current to damage the home? So again, all of that data is out there and available, and companies now are just beginning to scratch the surface of how it can be used. So hopefully I've been able to at least impress upon you the amount of data that's out there, and how fast it's coming at you, and how fast it's going to be coming at you. And so the challenge now is, how do we take all of that data? How do we take all of that information and begin to determine what it means, what it's telling us? And if you think about a lot of the types of analytics methods that are out there, those methods are continuing to, again, increase in complexity. So I'll start here, and the goal isn't to go through, although we're on the campus of a university, the goal isn't to go through the formulas and test you on those. But the idea is to talk about at least how this is progressing, at least in some jurisdictions, and talk about, again, where things might go. Historically, before the power of computing became what it is today, the analysis methods were, by today's standards, relatively simple, and they kind of had to be, because of the fact that to get a lot of the data, to be able to analyze that data, required pretty significant technical resources. Now, with, again, the power of technology, you've got the power of the cloud. The ability to analyze a lot of data is much simpler, and it's led to now being able to do more complex modeling. And so I point to this as an example. The use of things like generalized linear models, which are a class of multivariate linear models that allows the user to consider a number of different influences on a particular target. And ultimately, these models have been relatively easy to understand, relatively easy to kind of explain to someone that maybe doesn't have a technical background exactly how the model is working, and at least what it's coming up with. And so these have kind of grown in popularity, certainly in the US, but around the world in a number of different jurisdictions. The technology, or the state of modeling and methods, has really gone way, way, way beyond that. And I won't get into great detail, but the concept of machine learning did come up earlier. And if you think about all of the ways that analytic methods can really be applied, the list of potential, or the potential, I guess, is sometimes a little mind-numbing. But these methods and approaches are being developed and improved upon, it feels like, literally daily. And so there's more complexity, which allows us to take data that we may not have been able to get as much detail out of in the past, but to be able to understand it at a much deeper level. And so going all the way down to beyond regression to things like neural networks or deep learning really helps us, again, be able to dig into the many relationships that are present in databases to understand them better. And so, again, I don't bring this up to necessarily walk through every single method, but what I do want us to understand as we think about the future of actuarial models. The future of actuarial models, I think, is going to have to begin to contemplate, think about some of these more complex things, because that's where a lot of the world has gone. And I think we as actuaries are going to have to at least understand these types of things to continue to move our actuarial models forward. There are a number of considerations, though, and I do want to take a quick moment, take a quick step back, because one of the values that I think actuaries bring to this whole idea of models is that there's a domain expertise, there's a domain knowledge. We have a knowledge of the business that we're actually applying our actuarial skills to. And I think that gives us the ability to, I think, apply these kinds of methods in a smarter way. But there are a number of things that you should consider as you're thinking about how to go down this path. There's what really does apply, or what really does work on the underlying data. Ultimately, understanding the purpose or the target of where you're going will be important as well. are the results going to be used in a manner that requires frequent updating, less frequent updating? Is this something that I literally have to be able to do continuously, or is it something that will be done less frequently? There are a number of questions like that that will help determine what's most appropriate and which are best to be used. And so just because one of the things that we're learning is that just because a model may predict better doesn't necessarily mean it's the right model for that circumstance. So that's as we again contemplate the future of actuarial models, there will be a lot of options out there, but not every option is going to be a good one or the best one. The other thing, and this will also again be trend that the actuarial community will need to be aware of, is just all of the infrastructure improvements that are providing the ability for models to get much better. We've talked about data earlier, the ability to store more data, access it better, either through internal systems or through things like the cloud, has really improved our ability. The ability to process that data better. What used to take hours literally can be done in minutes or sometimes seconds. And then again, the ability to consume those results, the ability to take what we've done and push it out in a way that's understandable. All of these infrastructure improvements, I think, are laying the groundwork for a future where actuarial models can get to a more complex place. So the ability is there. Again, we will just have to make sure that the capability, to make sure that we do it in a way that doesn't necessarily turn off our ultimate users. As we started to look at this, one of the things that we wanted to understand was how much more ability to do what we do better is out there. And so this was just a simple example where we took what is kind of traditional now in terms of things like a generalized linear model analysis. And then once we did the best job we could with that, on top of that, applied some more sophisticated machine learning techniques, and then said, how much better can we do? How much more improvement is out there? And what we tried to do here is to show that, even when we did our best job with what we'll call the state of the art today, or maybe not state of the art, but what is more commonly used today, like a GLM. What we were finding is that there was still quite a bit more information that was present in the data, that was present in the analysis, that we weren't able to pull out based on traditional methods. And so, again, thinking about the future of actuarial methods, I think it does provide us with is some understanding that there is additional information, there is additional prediction, there is additional lift that is out there, and to the extent that we're able to go out and uncover that through more complex models, through using more data, it does allow us then to do a better job for the customers that we ultimately serve. So the last thing I'll end with, and then I want to make sure there's time for questions if anyone has any. But I wanted to spend a little time on the idea of applications, and I want to talk about it from a couple of different perspectives. Certainly, there are a number of applications in the actuarial space, in the spaces that actuaries maybe have traditionally been in, that we can certainly apply where the future of models are going to do what we've always done better. And I think that's been a lot of the focus of the use of actuarial models. But the way that data, the way that models are moving, and really the way that society is moving, I think is going to require us to maybe go beyond that. And I'll talk about what I mean by that here in a second. But let me just maybe highlight a number of applications, both some that are currently in place and then some that others are or people have talked about or thinking of, or maybe haven't progressed as far on in terms of general insurance. But when you think about models and actuarial models, the ability to use more sophisticated techniques and data, that ability is present throughout the entire insurance chain. So it's not just related to pricing as an example, or it's not just related to setting reserves. There's information that can be used to market better, to target customers better, to increase penetration. There's information that can be used to better underwrite, to better determine the types of risks that we're taking on in the insurance space, to do more refined pricing, to do more in terms of claims. But when you think about that entire cycle, there's opportunity throughout the entire spectrum, but then there's opportunity also to draw the right connections. And so the marketing isn't independent from the pricing or the claims, because all of that is going to have a connected impact. And so now I'm talking about not just building individual models, but models that could influence the stream. So again, as you think about the future of actuarial models, I try to encourage people to think that the concepts don't just apply to what actuaries have always done. The concepts of data and the analytics apply really anywhere. And so the future of actuarial models might not necessarily look like what we've always done, but it could require or could allow us to venture into to different places. So I want to talk about a couple of examples, and I want to talk about the examples not just from the perspective of what has been done, but how some of these examples might look different as we look into the future. So the concept of something like dynamic pricing came up earlier, and it's a concept that has different applications in different countries based on how insurance is regulated. So I do know in countries like the UK, as an example, or in areas like the UK, dynamic pricing is much more of a reality because there's less regulation than, let's say, someplace like the United States, where the regulation really doesn't make dynamic pricing a true reality. But in this particular case, what this showed is the ability to connect a number of different types of models to better understand pricing and how that pricing was going to impact the company going forward. So, when I change a price, it doesn't just, every customer doesn't just immediately renew and take that price. There are things that a customer can do that might impact what the ultimate price change looks like. And so being able to incorporate things like customer demand models, customer retention models on top of the pricing really helped, in this case, the company better understand exactly what they could expect when they implemented the pricing change. But as you just kind of think about the idea of dynamic pricing going forward, think about it in the context now of all of that additional data that we're looking at. So again, if I go back to all of the data being generated by the vehicle, and the ability to now dynamically price that the coverage for that vehicle, literally on a minute by minute basis, if I so chose. So as I'm getting real-time information from that vehicle, I'm now able to understand the risk and adjust the prices accordingly. And then it does potentially then go to the next step, which is beyond where we typically have been, but I think does require us to think differently. If I let's take Amazon as an example. If based on a lot of the stuff that we've bought, my wife has bought from Amazon, Amazon doesn't just sit and wait for me to come back and buy something else. Now, there are things that pop up in my email from time to time. There are things that pop up on my phone from time to time that say, hey, based on all the things that you bought before, here's something that you might be interested in, or here's something that you might like. And so Amazon is proactive at reaching out to me and saying, look, I know you bought all this stuff before. I found something cool that you might like. Do you want to buy it? Well, if you think about that in the insurance context, and how to potentially provide additional value to customers, if I, as a customer, am on a trip, wherever it is, and I've maybe happened to put in my destination in the navigation, does my insurance company know enough about me as a driver and about the routes that I'm driving to be able to say, look, I know this is probably the fastest way, but if you've got a little extra time, maybe there's a way to go that'd be a little less risky for you. And oh, by the way, I'll charge you a little less for taking this route versus that route. And so now we're starting to think about not just looking historically at what's happening and setting a price, but being able to now influence customer behavior in a way that allows us or allows the insurance company to become a partner with the customer and ultimately create a better outcome. And one of the it's an example that isn't necessarily, well, at least that I've seen, isn't necessarily been done yet. But if you think about the Amazon type effects or the eBay type effects that customers are used to, it's something that customers potentially might be interested in. The next one, if I've got time, we can come back and talk about the claims and the other. I do want to spend just a quick moment here before my time is up, because one of the things that's happening, and it's not just happening in insurance, but it's happening in a lot of different places, a lot of different industries. One of the things that happens when we begin to use more information and more data, one of the things that's happened is there have been some social concerns that have been raised. The more information, the more we know about our customers. Are we potentially using models in a way that has some impact on social fairness, as an example? The concept of affordability did come up earlier, and there are a number of different ways to define fairness, but one of those potential ways is through affordability. And so by refining our ability to understand risk more, are we potentially creating more social problems than we're solving by the use of insurance? And so one of the questions that's being asked more and more as the data gets bigger, as our ability to analyze it gets better, one of the questions that's being asked more and more is, are our models fair? And without getting into a whole discussion of what fair means, I bring it up because it's a question that I believe we as actuaries, as our models continue to improve, as our models continue to get more complex and rely on more data, it's a question that's going to be asked more and more. And so the more we are proactive in thinking about this idea of fairness and whether our models are actually discriminating or not, I think the better we will be positioned as models continue to get better and better. And at least one of the ways I tend to think about this idea is to think about, as we do the work that we do, as we build the actuarial models that we build, there are certain things because of what we've all agreed to as a society. There are certain things that we would never incorporate. There are certain things that we would never use to build those models. Well, the concern or the worry, and this has been, again, shown in other industries, the concern is that as the data gets more and more complex, as it gets bigger, as we know more and more about a customer, are we potentially, are we unintentionally getting to a place that we said as a society we would never go because of these things that are prohibited to be used in data or in modeling? And if we're getting too close to that line, now what's the actual responsibility in that particular case? And so there is a whole, we won't go through this, but there is a whole series of research that is continuing to be done on how to kind of understand fairness from an actuarial perspective. Certainly, the models, the prices, the things that we do have to be based in data. That's what we as actuaries do. And this idea of fairness doesn't necessarily get away from that. But it does build constraints around what we do, so that we aren't unintentionally going to a place that we said we wouldn't go. So again, as we think about the idea of the future of models, it won't necessarily just be about measuring risk, and then providing to our ultimate customers, be it insurance companies or others, an understanding of what that risk is. It may require us to think differently about how do we proactively address customer concerns or deal with customers, or how do we deal with this idea of fairness so that we can, again, do the best job that we can with our models, but make sure that they are fair. So ultimately, I think I will end here. And again, we'll be happy to take any questions that you have. But as you think about the future of modeling and you think about all of the possibilities and where it could go, it could get overwhelming. There's a lot of potential out there. And one of the things that I would encourage, each of us to do, and I encourage people to do when I talk about this, is you think about it in terms of your business strategy and in terms of your business plan. There are many different ways, many different tools, many different approaches that you can begin to implement to help get to the plan. But the key is, don't start with the data and try to find a solution. Don't start with the model and try to find the right solution. Start with the problem you're trying to solve. And when you define that problem, then you define the right data, then you define the right approaches, and that ultimately will lead to the right outcomes. And as you think about that cycle I showed earlier, as we talk about the future of models, it's only going to get bigger and it's only going to get faster. And so again, our ability as actuaries will have to adapt to that world getting bigger and that world getting faster. Again, it's been my pleasure to be with you today. Hopefully I said something that was helpful. And although I won't get to spend a lot of time in Mexico City this time, it's my first time in Mexico City, not in Mexico. I really do love the city so far, and I will be back. So thank you.
Very much, Roosevelt, for your presentation. I think it's been very enlightening and very useful for all of us. And thanks for being here. We know you just arrived yesterday at midnight, so we really appreciate. I don't know if there's ¿hay alguna persona que quiera hacer alguna pregunta? Maybe you have time to address a couple of questions. ¿Alguna pregunta? ¿Nos ayudan, por favor, con los micrófonos?
Hello, thank you very much for your presentation. I enjoyed it very much. I was looking at your circle and specifically this step of validation. I think that during some time I have been concerned about this validation step. It has been an ongoing discussion about this thing. And I was particularly interested in the example that you told us about Google, no? And you were able to validate, or at least say that something is wrong, no? That essentially the translation cannot be accurate. And of course, I mean, that implicates that there is going to be a cycle where actually the model is going to be refined and improved. But when it's about pricing and specifically with certain topics in actuarial sciences, it's difficult to do this validation process. For instance, if I given a premium for I don't know, a car insurance or whatever, I'm not sure if actually that's correct, or even if I know, well, the risk perhaps involved is much higher, or I should get a lower premium, I won't be very successful in going to the insurance company and say, okay, look, this is the wrong premium you're charging me, perhaps you're overcharging me. So I don't know if you can share a little bit about your perspectives or what are the challenges about this aspect of model validation in the actuarial sciences or actuarial models?
Yeah, and that's a very, very good question. And well, I won't say the limitation of showing it this way is that it feels like it's a very linear or very, one step, move to the next step, move to the next step. And honestly, if I drew it the way it happens in practice, you would see lines going all over the place. There's kind of two versions of model validation that I think really speak to what you're talking about. The first is if I've got a data set that I'm using to build a model, then typical model building approaches won't say require, but best practice says you hold out part of that and you use that to validate the models you build. The problem with that is unless your data is so comprehensive that it covers all situations, it's not going to be a model that will apply potentially appropriately to everything. And so as you get through the implementation and monitoring, now what you'll be able to determine is the model potentially being applied in situations it was never trained for? And so that, if you think back to that's kind of what's happening with Google Translate. It's being applied in a situation it wasn't trained for. And as a result, it's not behaving very well. And so now you enter into what I'll call post-implementation validation, which says, I know there are some areas that the model wasn't trained well for. And so it could require me now to go back to my model and determine how to best incorporate that information as I get better. Does that help?
Gracias. ¿Alguna pregunta adicional? Tenemos una pregunta por la parte de allá arriba. There's one more question. Yeah, it's on the top. Here.
Oh, sí.
Hi, thank you for the presentation. I think it was very useful. We talk about the calibration and trying to implement these complex models, but actually we have not discussed anything about disclosure of results and properly communication to non-actuarial intended users, maybe. So any recommendations in this part of implementation?
Thank you. Good question. And I didn't spend very much time on that. You're correct. The slide I showed that talked about considerations for models as you choose models, that certainly is one of the considerations. So there's some questions you have to ask up front, and oftentimes, at least in our business, the goal isn't to just predict well. There also has to be the ability to explain what the model is predicting. And so that's why I made the statement earlier that the best predicting model or the most complex model might not necessarily be the right choice for the situation that you're in. But there's a couple of things. One is you're correct. Being able to explain the models that you're building is going to continue to be important. And so either that means one of two things. I either have to limit my complexity, or there are tools that are available that try, or techniques that are available that try to help explain complex model results in simpler terms. And so a lot of that science is still developing, but it does hold some promise for being able to still use complex models. But you're correct. Part of determining which models you can or should use, part of that depends on how much you have to explain it to a non-technical audience.